In the vast expanse of space, astronomers have discovered a class of planets so extreme they defy our imagination. Welcome to the world of superhot Jupiters. Meet WASP 121b, perhaps the most extraordinary of these cosmic giants. This massive planet orbits so close to its star that its atmosphere glows with an eerie metallic light. The surface temperature of WASP 121b reaches a staggering 4,400 degrees Fahrenheit. That's hot enough to vaporize iron, titanium, and most metals we know. At nearly twice the size of Jupiter, WASP 121b dwarfs our solar system's largest planet. But unlike Jupiter's relatively cool atmosphere, this world is an inferno of unimaginable proportions. Its atmosphere is unlike anything we've seen before. Here, metals don't just exist as solids or liquids. They become luminous gases, creating spectacular clouds that shimmer with metallic hues. These superhot Jupiters serve as nature's most extreme laboratories, showing us how matter behaves under conditions impossible to recreate on Earth. WASP 121b orbits its star at a mere fraction of the distance between Mercury and our Sun, completing one orbit in just over a day. This proximity is what drives its extreme conditions. Every aspect of WASP 121b pushes the boundaries of what we thought possible for a planet. Its discovery has forced us to rewrite our understanding of planetary physics. From its molten surface to its upper atmosphere, each layer of this world tells a story of matter existing in states we never knew possible. As we venture deeper into understanding these extraordinary worlds, we're about to witness how WASP 121b and its siblings challenge everything we thought we knew about planets. On superhot Jupiters like WASP 121b, the concept of atmosphere takes on an entirely new meaning. Here, metals don't just exist as trace elements. They form the very fabric of the sky. The atmosphere is a swirling cauldron of vaporized metals. Iron, titanium, and other metals glow with their own light, creating clouds that shine in brilliant, otherworldly colors. At temperatures over 4,000 degrees, iron doesn't just melt. It becomes a glowing gas that moves in waves through the atmosphere, much like water vapor does on Earth. These planets experience a unique metal cycle. Intense heat vaporizes metals in the lower atmosphere, which rise as gas before cooling and condensing into droplets of liquid metal rain. Imagine raindrops of pure molten iron, heated to thousands of degrees, falling through clouds of glowing metal vapor. This isn't science fiction. It's the daily forecast on WASP 121b. Each metal in the atmosphere contributes its own unique color to the sky. Iron glows in deep reds, while titanium vapor adds brilliant blues and purples to this cosmic light show. Scientists can identify these metals by analyzing the light that passes through the planet's atmosphere. Each element leaves its own distinctive rainbow fingerprint in the spectrum. The atmosphere of these worlds is in perpetual flux. Metals constantly transition between vapor and liquid states, creating a dynamic, ever-changing skyscape. The extreme temperature differences between the planet's day and night sides drive powerful winds that carry vaporized metals across the globe at speeds exceeding thousands of miles per hour. Every second, as metal vapors rise, cool, and rain back down, they create spectacular light shows that would make Earth's most dramatic sunsets look pale in comparison. The interaction between starlight and these metallic clouds creates prismatic effects, unlike anything seen elsewhere in nature. It's a reminder of how extreme conditions can create extraordinary beauty in our universe. Superhot Jupiters live on the edge of destruction, performing a dangerous orbital dance with their host stars that pushes the limits of planetary survival. Take WASP 121b. It orbits so close to its star that the immense gravitational forces have stretched it into an egg-like shape. At just 2 million miles from its star's surface, it's literally being pulled apart. These planets complete their orbits in mere hours or days, whipping around their stars at speeds exceeding hundreds of thousands of miles per hour. The intense stellar radiation bombarding these worlds is so powerful, it literally tears their atmospheres apart. The stripped material forms glowing tails, like cosmic comets, streaming behind these planets. In the upper reaches of these planets' atmospheres, something extraordinary happens. The extreme conditions create unique crystalline structures that shimmer and dance in the stellar wind. These crystal-like formations act like cosmic prisms, catching and scattering starlight in spectacular displays. They form and dissolve constantly as the atmosphere gets stripped away into space. The gravitational forces at play are mind-boggling. The planet is squeezed and stretched as it orbits, generating enough internal heat to make it glow visibly in space. These planets are living on borrowed time. Each orbit brings them closer to their eventual destruction, as their stars slowly but surely consume them. With each passing year, these planets lose massive amounts of their atmospheric material to space. Some are estimated to lose the mass equivalent of several Earth atmospheres every billion years. Hey everyone, if you're fascinated by these incredible worlds like I am, make sure to hit that subscribe button. We're exploring the most extreme places in the universe, and you won't want to miss what's coming next. The magnetic fields between these planets and their stars create incredible displays of energy, generating massive electrical currents and auroras that would make our northern lights look dim in comparison. These dying worlds provide an unprecedented window into the extremes of planetary physics, showing us just how far the laws of nature can be pushed before a planet finally breaks apart. Super-hot Jupiters like WASP 121b don't just push the boundaries of physics. They shatter our fundamental assumptions about how planets work. Traditional planetary formation theory tells us that gas giants should form in the cold outer regions of solar systems. Yet here are these massive worlds, orbiting closer to their stars than Mercury does to our Sun. By all normal physical laws, these planets shouldn't exist. The temperatures and forces they experience should tear them apart almost instantly. Yet somehow, they persist. The atmosphere of these worlds behaves like no fluid we've ever seen. The intense heat creates supersonic winds that move in patterns that contradict our understanding of fluid dynamics. Light passing through these atmospheres encounters conditions that exist nowhere else in nature. Each layer acts like a cosmic prism, but the rules of refraction and reflection work differently under such extreme pressures and temperatures. At these temperatures, the behavior of matter begins to blur the line between classical and quantum physics. The atmospheric particles exhibit properties that challenge our understanding of both realms. The intense conditions cause molecules to break apart and recombine in ways we've never observed before. Chemical reactions that are impossible on Earth occur freely in these extreme environments. These planets push matter so far beyond normal conditions that new states of matter may exist in their depths, states we haven't even discovered in our laboratories. Deep within these worlds, matter exists under such intense pressure and heat that electrons and atomic nuclei might arrange themselves in entirely new structures, defying our classical understanding of materials. The way light behaves in these atmospheres breaks all our normal rules. The extreme conditions create optical phenomena that shouldn't be possible according to standard physics. As starlight passes through these superheated atmospheres, it splits and bends in ways our physics equations can't fully explain. The result is a light show that defies our understanding of optics. The discovery of superhot Jupiters has completely transformed our understanding of what's possible in our universe. These extreme worlds are rewriting the textbooks of planetary science. Before we found these worlds, we thought we knew what planets could and couldn't do. But superhot Jupiters like WASP 121b have shown us that the universe is far more creative than we imagined. These planets don't just exist at the extremes, they create entirely new categories of physical phenomena. Each discovery pushes the boundaries of what we thought was physically possible. Our most advanced telescopes are revealing new mysteries about these worlds every day. The unique signatures we detect in their atmospheres hint at exotic chemical processes we never knew existed. The study of these extreme worlds has united different branches of science in unprecedented ways. Astronomers work alongside chemists and physicists to understand these natural laboratories of extreme matter. The conditions on these planets create natural experiments that we could never replicate in Earth-bound laboratories. They're teaching us about the behavior of matter in environments we never knew existed. We now know that these extreme worlds are surprisingly common in our galaxy. Their existence suggests that planetary systems can form and evolve in ways we never considered possible. Every time we think we've found the limits of what nature can create, worlds like WASP 121b remind us that the universe has more surprises in store. The next generation of telescopes and instruments are being designed with these planets in mind. Their study is driving innovation in how we observe and understand distant worlds. Super-hot Jupiters have become windows into the unknown, showing us that the universe is capable of creating conditions far more extreme than we ever imagined. As we continue to study these extraordinary worlds, one thing becomes clear. We're just beginning to understand the true diversity and extremes of planets in our cosmos. Thanks for joining me on this journey through the most extreme planets ever discovered. If you enjoyed this exploration of cosmic wonders, don't forget to like and subscribe for more adventures through space. Until next time, keep looking up and wondering what other incredible discoveries await us among the stars.